Hello and welcome back to the course on Google Cloud Platform. This video we will take a look into Cloud Composer. So Cloud Composer is a fully managed workflow orchestration service that built on top of Apache Airflow. So if you look into the properties, it's a fully managed workflow orchestration. So workflow in the sense like you can create different stages and all are connected together and we can define the logic. And it can integrate with other Google Cloud products. So for example, from Cloud Composer, you can deploy a new Dataproc cluster or you can do something with the BigQuery and then you can execute some Hadoop or MapReduce or Hive or Spark job on Dataproc cluster, then you can terminate. So this workflow you can define and that it can make use of other Google Cloud products. So as I said earlier, it helps you to author. That means you can create, you can schedule and monitor the pipeline. Pipeline means the set of dependent tasks. And Cloud Composer is basically built on top of Apache Airflow and we can use Python code in backend to define the workflow. And next we will do a simple demo and we are following the Google's official documentation and they have mentioned how to create a cluster, Dataproc cluster, which is nothing but a Hadoop cluster, and you can define the DAG. DAG is something like the set of dependent tasks. We are defining that task into a Python code and basically we are deploying a Dataproc cluster, creating a new Dataproc Hadoop cluster, then executing a sample word count MapReduce job, and once that is finished we will terminate. All these things are done as part of a DAG, direct acyclic graph, which is nothing but set of dependent tasks. So if you look into the high level, see these are the tasks that we are going to perform, and see the first we will deploy a Cloud Composer. So you have to log into the Google Cloud and we have to create a Cloud Composer environment. Then we need to create a storage bucket. So this is for storing our output. Okay, so we are storing our output into this file, and definitely we need to add some variables in the Airflow. Basically this storage location, then the zone where we want to deploy Dataproc cluster, etc. we will define as a variable in Airflow. Then we have a DAG definition file, which is nothing but a Python file. Okay, so based on our requirement we can make some changes into this file and that we will be uploading into Cloud Composer's storage location or storage bucket. And then we will monitor the pipeline. So whenever if we need it, we can rerun or we can monitor those things. Now let's go to the demo. So this is the documentation page. You can open this page and go through at least once. So this explains what are the tasks that we are going to perform. So we are creating a Cloud Composer environment. Then we are creating a storage bucket, then uploading this to Cloud Composer storage location and run the pipeline. So first log into the cloud environment using console.cloud.google.com, and from here hit here and just to go to the Composer environment. Maybe it's on the bottom. Okay, you can see here Composer. Select that and create an environment. Okay, so click here to create a new environment. Then give some name. Okay, so nextgen-demo, any name you can give, the location where you want to deploy. So you can use it in US Central or wherever the location which you feel comfortable. and the machine type, the type of machine that you are going to use for this one, and remaining things you can leave it as default. Then create. So normally it take a few minutes, maybe 10 to 15 or more. So even if it's taking much time, don't worry. So you have to wait until this deployment get completed. Now the deployment has completed. So you can see the Cloud Composer environment is here with the green, and you can just view the configuration and can see the detail. So mainly you need to focus on these two, like DAGs folder and Airflow Web UI. Okay, so the DAGs folder basically a storage bucket where we need to upload our Python code. So by default you can see the Airflow monitoring.py, one DAG file already exists. Second is like the DAG Airflow URL. Just click this and just select the account where you choose, and choose the same account to log in. You can see one DAG is running. So this is the corresponding file available here. So what we need next is we need to have a second storage account or storage account bucket for storing our result file. So open this console again, and I'm going to create a new storage bucket. Then you can click here, or from here select the storage and select storage, and go ahead and create a new bucket. So you can see the existing storage. So this storage account or storage bucket corresponds to the Cloud Composer one. So I'm going to create a new storage account and just use nextgen demo storage and continue. And you can choose the location type like region, dual region or multi-region. Since it's a testing environment, I am not concerned about the availability and all. And choose the location, so whichever you feel nearby your place. Okay, and then continue. Then choose the remaining things as default, and then continue. Then create. So this will create a new empty bucket. So this is the name and the bucket detail. You can get the full URL here. In this example, so you can download the sample file, and they have given the Git repository location, and this is the file. Okay, so if you look into this file, so this is the Python file and importing some modules, and this part. Okay, so this is the variables. So these are the variables that we are using here. Then output file, the location, you can see this GCS bucket. So models.variables get. So whatever the variables that we define here can be accessed using this code, and word count, and then concatenating this. So this is basically the output location. Then the word count jar file. So this is the location in the cluster where our example jar file located, and the input file. So input file we are using from some public repository, and pub then Shakespeare rows.txt. This is the file we are using as an input, and word count argument we are using as word count, input file and output file. So input file and output files are variable that we have already defined here. Then we are getting yesterday's time. The reason why we are using yesterday's time is to run the pipeline immediately once we upload this file. Then default arguments. So these are the arguments that we are passing to the DAG class while creating a DAG object. Okay, you can go through this and try to understand. Again, I will be explaining this in detail in upcoming videos. and we are creating an object for DAG, and then we are assigning a variable and calling this function. So cluster create operator. So what we are using, doing here is, first we are creating a Dataproc cluster. So with this option, okay, so this much option we are using, and we are going to create a new Dataproc cluster. So the task ID, the ID of this workflow task, and the cluster name, the name of the Dataproc cluster. So the number of workers, the zone where, okay, here you can see the zone, it's a reading from the variable. So models.variable get, okay, somewhere we used models.variable get, like GCP project and the zone and the project and bucket name, etc. we are getting from the variable, and the master machine type and worker machine type. So only one thing I changed here is like the master and worker machine type. When I tried with this type of machine, it was not working. And also I added one option. I'll just show my file, okay, so that whatever the changes I made on this file, because directly when I tried to upload this file, my deployment was failing. And the next task you can see, so this is for running a Dataproc Hadoop operator. Okay, there are a lot of different functions available for running Hive job, different for running big jobs, Spark SQL, Spark. There are different jobs available based on our requirement. You can just explore those options. And the last, okay, so we are going to delete. And here you can see the trigger rule. So basically all the previous operation is success, then only the next stage will get executed. But here we don't need to wait until the previous is success or not. Even if it's failed, we just need to delete the cluster. And we are defining that flow. The first is the create Hadoop cluster. So create Hadoop cluster, this is this one. And the next is run Dataproc Hadoop. So run Dataproc Hadoop, that is this stage, okay. And the last, delete. So this is how we define the flow. This is called a direct acyclic graph or DAG that we defined in this Python. So you just need to go through this various Python code, and there will be a lot of sample code available in internet with the different jobs. So here we are going to create a Dataproc cluster, executing sample word count, then saving that result into this one storage location. So that is a storage bucket we created, and last it will terminate the cluster. I'll just show you the file which I created, and I'll just explain what are the changes or additional option I added. So once Composer is deployed, so we can go to this Airflow Web UI and add couple of variables. Okay, so go to the admin, then variable. So I have already added this variable. I'll show you how to create a new variable. So these are the variables which I added: GCE _zone, GCP project, and GCS bucket. And these are the values. So how to add that? Just go to the create and then go ahead and add the key and the GCS bucket and its value like that. Okay, so I added these 3 variables, and we will be using this inside our script. So next is like DAGs folder. So this is the storage bucket where we need to upload our Python code. So already you can see one airflow monitoring.py Python script available. So we will be uploading our script. So before uploading, I will show you the script which I have downloaded and modified. So this is the script which I used for defining our new workflow. And here you can see there is a slight difference. Okay, I have added the image version, then the master and worker machine type. So you can see this GCE zone and some other GCP project. So these variables, we have defined there like GCS bucket. So we will just use the models.variableGet function to get that value stored in this variable. So these are the variables that we have defined in the Airflow. And basically it consists of 3 tasks. You can see under DAG, it's a create Dataproc cluster, then run the job, and then terminate or delete. And that we define the DAG dependency like this. So first create, then run, and then delete the cluster. So we are going to upload this into this bucket. So upload file, and then use the file, and then upload. So once this is uploaded, then back to the Airflow console, and just to go to the DAGs and wait some time, and you can see one more DAG will be added here. So based on the file we uploaded here. Okay, so this is the file which I downloaded from the Google's repository. So this is the repository, but the image name and image, the worker and that worker and master machine type and image name I added into the script. That's the only modification I did. And keep refresh, maybe sometime soon you can see one more DAG. Yes, this is the one. And if you click here and go to the graph view, so you can see this already started running. So started running, you can see the 3 stages. Okay, the first one is creating the cluster, second is run the job, and third is termination. Then the creating cluster, if you go to this Dataproc, okay, you can see the cluster is provisioning. So this started deploying the cluster, that's why it's showing here. And once this is done, it will run the MapReduce job. And then once that job is completed, or even it's successfully finished, or if in case of error, whatever the cases, it will delete this cluster. So let's give some time to complete this process. You can monitor the same from here. Just click here and hit this view log option, and you can see the log file in detail. See, this is deploying the Dataproc cluster. So maybe once this is done, it start executing the code. Okay, it's yet to start. Let's wait here for some time. Okay, so this is showing us a running state. Now maybe just refresh here. See, you can see the job started running. So once the job started running, it will write the file into the storage account we have given. Okay, so this is the storage account we have given for output of the MapReduce job. You can see the word count directory is created and see the content. So this is still writing the content, and you can see all the files. The word count output file generated. Okay, so once this is completed, okay, this is success. Maybe it will start in a moment. It's showing us queued. So queued, and immediately it will start. So the flow is the first to create the cluster, then run the job on that cluster, and once this is done, it will clean the cluster. You can see that most probably the cleanup might be just starting. So this is deleting the cluster. So you don't need to pay, if your cluster is waiting, you can just utilize the cluster only for submitting your job. This ensures minimal cost on your cloud resources. Okay, so just because the page is not loading dynamically, I think we need to add some settings to do it quickly, but otherwise the page is updating slowly. Maybe just refresh, it's running. So once this is terminated, you can see this is finished. And you can for each stage you can view the log file from here, like view log option will list the log. Okay, then back to the graph view and see the status. This is also success in the sense this is already deleted. So here you can see the stages are there. I mean the dependent the list of dependent job. So one has finished and then the next has finished, then completed other. So this is how the job flow works in Cloud Composer. This is very easy. The first step is to deploy an environment. Second is generate the Python file for defining your workflow and keep that Python file into this location. Then if you are using some variables, use this Airflow Web UI and add those variables. Then the next step is make those changes in the Python code. So once this is uploaded, you can see in the DAGs list whatever the Python you have uploaded. And you can see the status and view the detail log. There is a graph option, tree option, and these are available. So you can explore this each and every feature later, but this is just an overview. Hope this is clear, and we will see in the next topic. Bye.